okay, right? So here we go, right? Remember we said that Noah's 5 feet 8 inches, Julia's 5'6", Nick is 6'4". I have those inserted, and I've already started to draw my diagram for Noah and the flagpole here. So we have Noah over here, 5'8" right? Let me make that into 68 inches tall. That's going to be easier. And he's standing 5 feet from the base, so we'll make that 60 inches there. Okay, for ourselves. And let's see. So he's going to be, and he measures the angle of elevation at the top at 70 degrees. Okay, so here's where that 70 degrees is. Okay, right, it's right there. Okay, there's where my 70 degrees is. Right, so we know we're just basically trying to figure out how tall the flagpole is. So you can see the flagpole is broken up into two parts. The part that's here, which we know is 68 inches, and then we have this part up here, okay, which is the part that's above Noah. So this is where Noah is, right, and this is what's above him. So we're going at 70 degrees. So if we're looking at that triangle, let me highlight my triangle in the second color here. Right, here's my triangle that I'm dealing with. Okay, and I'll actually draw it over here separately too as well, so to help you to see it. So we have a 70 degrees. We know that this is 60 inches. How do we know it's 60 inches? Because that's how far Noah is away from the flagpole, and we're trying to figure out how tall the flagpole is. So that's this right here, right? That's how tall, well, at least that's the part of the flagpole that's above the 68 inches. So I look at this and I say, okay, opposite, adjacent, so I use tangent. Okay. Go to my trig table. 70 degrees. Go across the tangent. 2.7475. Multiply by 60. Okay. Take out the calculator, and I do 60 times 2.7475. And that gives me 164.85. Okay. Now keep in mind that that's this length right here, that's this length right here. Okay, so what do I need to do that? I need to add that to the 68 I had before for his height. And now I'm at 232.85 inches or so. We're going to round it off because the directions tell us round to the nearest inch. So we're going to be at 233 inches. Okay. So there we go. Okay, so hopefully that makes sense to you. Now, if you needed an explanation to do example 4 here, right, then this would be a great time to pause, right, try example 5 for yourself, and then watch what I do for it to make sure you're doing it right. Same thing when I get to example 6. Pause, right, and then try it on your own. Okay. Now I'm going to do those now, right, so you want to hit that pause button if you want to try it on your own first. And I would highly suggest you at least try to draw it out yourself before looking at what I did. That's going to help you. Okay, so Julia's cat has gotten stuck in a tree. She is standing 10 feet from the base of the tree and finds that the angle of elevation is 73 degrees to her cat. Okay, so ground, cat in the tree. So we'll just put the cat up here. All right, I'm not going to worry about making the perfect tree. All right, but there's the cat in the tree, and now here's Julia over here. Okay. As we said, 5 feet 6 inches, which is 66 inches tall. And we're just going to put everything into inches so that we don't have to deal with, feet is kind of annoying in terms of how we deal with it, right? And it's 12 inches in a foot, so just change it to inches so that it makes it easier. She's 10 feet from the base. All right, so 10 feet right here. I am going to change that to 120 inches. Okay, and the angle of elevation is 73 degrees, right? So just something I kind of meant, I didn't really go through. The angle of elevation is always off the horizontal, right? So that's basically how, if you were going to look up, like what angle are you looking up at? So we'll put that little note there. Okay? That's what angle of elevation means. Okay. If we look at our triangle, the actual triangle we have here, right? There's the rectangle underneath, but the triangle right here, once again I'll draw it separately. 73 degrees, 120 inches. And we need to know how high the cat is in the tree. So remember that this right here is not actually how tall it is, it's just in the triangle how much above Julia is, how much taller the cat is, or sorry, how much higher the cat is than Julia. So I'm looking at this opposite and adjacent, that's a tangent. Okay, go to my trig table, 73, read across till I get the tangent, that's 3.2709 x over 120. Okay, we're going to multiply both sides by 120. And now you really have to have a calculator to do these. Okay, so I get 392. X is 392.508. Remember, that's how much higher it is. I'm going to add it to the 66. Right, so 392.508 plus the 66. 458.5. We're rounding off to the nearest. Did it say the? Yeah, we're going to do the nearest inch again. I'm sorry, I forgot to say that there. But right, we had it in the other one, and all these problems we're going to do to the nearest inch. So 459 inches. That for me, I'm like, I can't really visualize that. I'm going to take that 459 divide by 12. So that means it's 38 feet, and 38.25 feet says. So 0.25 feet is 3 inches. Okay, so that's probably your better answer, 38 feet, 3 inches, just so you can kind of understand how high that tree is there. So Julia's going to have to get quite a tall ladder to get that cat out of the tree. So, last one, Nick. Nick doesn't like to go on roller coasters that are too tall. When he stands 100 feet from the coaster. By the way, again, if you needed me to talk you through that, pause the video here, try the next one, and then attempt the problem. Okay, use the pause button a lot, right, to help you to not just watch me do it, but to try it on your own. When he stands 100 feet from the coaster. Okay, so coaster. Nick, 100 feet away. Nick, coaster, 100 feet. Nick is 6 feet 4 inches, or 76 inches. Now at this point, maybe you don't want to convert it over to inches because he's standing 100 feet away, and that's a lot of inches. And if you're not a big fan of that, then you just have to convert this to decimals. Right? Or maybe you just hold off and you keep, you worry about that later. Okay, let me show you how I can do that. Okay, so we'll leave that, and I'll put 100 feet right here, and I'm going to put that feet label. Okay, I'll show you how we can do this. Right? And then here's Nick looking up, and it says his angle of elevation is 47 degrees. Okay, again, whoops, we're working with this triangle right here. Okay. So if I'm looking at opposite over adjacent, so it's the tangent 47 equals the opposite over the adjacent. Okay. A lot of times these indirect measurements, they're going to be tangent. So expect that when you're doing these. I go to my trig chart, I look at 47, I read across till I get the tangent, which is 1.0742. No, I said 42. 1.0724. Okay. Then I'm going to multiply both sides by 100. I have to solve for x. So I'm going to take 100. Actually, this just move the decimal place over 2 spots, so 1, 2. So we're at 107.24. And that's in feet. Remember, this was in feet here, so that's in feet. Okay? So, if we're doing this, and we're going to need to round to the nearest inch, then you don't round here, because that's rounding the nearest foot. So that's why it's sometimes better just to change it to inches. But if you're going to do that, right, 107 feet, and then 0.24 feet, you go to your calculator, put 0.24 times 12, and that tells you how many inches. So it says 2.88, which rounds up to 3 inches. Okay? So we have 107 feet, 3 inches. We're going to add that to Nick's height of 6'4". Okay. And that means that in all, this roller coaster is 113 feet, 7 inches. We should put, alright, that's the height of the roller coaster there. Okay. And you would have gotten the same thing if you converted this to inches at the beginning. If you did 1200, you would have had, this is 1200, you would have had, you know, a whole lot more inches. You would have added to 76, but you really should convert it back to feet and inches, because it would have given you such a giant number that it wouldn't have made sense. Okay, so hopefully you that I've explained that well enough for you. That makes sense in terms of how I set up each of those problems. Right, at this point, you want to try to do your best on the homework. Right, packet, and I'm going to do the same thing. I'm going to talk you through all the solutions for the homework packet, 1 page at a time, so you can go back and look at it if you're still having trouble. Okay, so I hope that helped. Email me if you have questions, and good luck on the problem.